These are the solutions to 2024 CCEA Mathematics A21 paper, which was a fairly tricky paper. Okay, we have got, first thing on your first page, it tells you 3 sig figs for answers unless otherwise told otherwise. And so the first question says, write as a single fraction. So what you want to do here is cancel down anything by using a wee bit of factorization. So we'll write x plus 3 is our top line. The bottom line, that could be factorized to be x plus 3, x minus 5. And then that's just minus 1 over 2x minus 7. So let's just put that in a bracket, and then we're going to cancel this out. So that cancels. So when you cancel that, really what's happening is the x plus 3 divides into itself one time. So that's what you get. So really what you've got now in your next line, it's just equal to 1 over x minus 5, then minus 1 over 2x minus 7. So take a common denominator of x minus 5, 2x minus 7, and then top line is going to be 2x minus 7, and then minus x minus 5. And we sort out that top line, 2x minus x would just be x, minus 7 minus 5 is minus 7 plus 5, which is just minus 2. And then that is just x minus 5, 2x minus 7. That's all we can do there. Next part of the question, we've got to simplify the following algebraic expression. So it's just factorizing again. So factorize everything here. So it's 3 upon x squared minus 9. The bottom line here will become 3x plus 1. Use your sum and product to do that if you need to. 3x plus 1 upon 3x minus 3, and then divided by, and that's going to be 3x plus 1x plus 3, again using your sum and product, and that's just x minus 7. Put that in a bracket, just makes life a wee bit easier to see if there's any cancelling that happens. Next thing I'm going to do is, well, I'm going to factorize this top line again. X squared minus 9 is x minus 3, x plus 3. And the bottom line is 3x plus 1 and x minus 3. And then what I'm going to do is flip the dividing fraction and change the divide sign to a multiply. And only at this stage should you think about cancelling. So we can cancel now then. And there's an x plus 3 there. We'll go into itself once. X plus 3 go into itself once. What else do we have? That is it. And that's all we can cancel. Oh, sorry, no. Silly me, didn't see that. You've x minus 3 and you've an x minus 3. And then that is now all we can cancel. So multiply along on top, you have 3 times x, 3 upon x minus 7. Bottom line, you're going to have 3x plus 1 upon 3x plus 1, or 3x plus 1 squared. And to be honest, I would leave it like that. That's pretty good, pretty nice way of writing the answer. Okay, question 2, a series question. Write each of the following series using sigma notation. So first of all, let's get the general nth term of this thing, and then we'll figure out how many terms we have. Okay, we're going up in 4s every time, which tells me there's a 4n involved. And if I went back here, that would back by 4, that would take me back to minus 11. So it's 4n minus 11 is my general term. Now we've got, this is clearly the first term. We need to find what term number this is. So let's put 4n minus 11 equal to 25, which means 4n is equal to 25 plus 11, so 36, and then works out to be the 9th term. So our sequence is the sum from n is equal to 1 to n equals n of that. So that should get your 2 marks was just for that one, sorry, 2 marks. This one, right, you've got 16, 9, 4. So working backwards, I'm going to think that's the square numbers. So I'm going to write my 6 as 6 over 1. So then my top line is going up in 1s every time. So it's going to be an n. So it's n plus 5. So my nth term is n plus 5 over n squared. So that is my nth term. Okay, and it is a sequence, series I should say. So we'll just say n is equal to 1, and then it goes up to infinity. Let's see, the dot tells you it goes on forever. So that's what it is. So I would imagine you get 2 marks for this and a mark for this bit here. Next bit here says a sequence is defined using the recurrence relation. so this, to get my next term, I do A times my current term, and then whatever that was, add B. And then we're told what our first term is. So it's first term, second term, and third term. So to get my second term, I'm doing A times my first term, and then adding B, which means 210 is equal to 150A plus B. And then to get my third term, I would do A times my second term, and then add B, which means 288 is equal to 210A plus B. Dot, 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 equation 1, dot, 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 equation 2. We know where we're going now. So I'm just going to do, well, here, I'll just write those down very quickly underneath each other to make life a wee bit easier for myself. Equation 1, and then my equation 2, and then I'm just going to subtract. So I will just do subtract here. I'll get minus 78 is equal to minus 60A. That was equation 1 minus equation 2. Divide across, then that's just going to be 78 over 60 is equal to your A. My A works out to be 13 over 10. And then sub it into equation 1. I'll have 210 is equal to 150 times 13 over 10 plus B. That means 210 minus 150 times 13 over 10 is going to be equal to my B. So my B works out to be 15. So I've got my A is equal to whatever it was, 13 over 10. I'll write that as 1.3, and my B is equal to 15. Oops. Okay, differentiation question here. It says differentiate the following expressions with respect to x, simplifying where possible. So you've got, this is a product. So I'm going to write my u is equal to x squared, and my v is equal to ln of x. So du by dx is equal to 2x, dv by dx is equal to 1 over x. So dy by dx, if you've got a product, is v du by dx plus u dv by dx. And then just fire that all in. What was my v? My v was ln of x times my du, which is 2x, plus my u, which is x squared, times my dv, which is 1 over x. And then that's just going to be 2x ln x plus x. And that's it. 4 easy marks there. Happy days. Next one, another easy one, quotient. Your u is equal to 3e to the x squared. Your v is equal to 2x to the 4. So du by dx. Okay, so if you differentiate a quotient, so let's just write this wee thing down. If y equals e to the f of x, your dy by dx then would be f dash of x e to the f of x. So the power stays the same, much like if you differentiate a sine or a cos, the angle bit stays the same. So here, differentiate x squared, you get 2x. So that 2 times 3 is going to be 6x e to the x squared. Differentiate this, dv by dx is going to be equal to 8x cubed. And if you have a quotient, u over v, it's v du by dx minus u dv by dx. So because of that minus, it matters which way around you put those, and that's all over v squared. So we've got everything, have we? Let's see if I can get this squeezed down the page here that we can see this. So my v was 2x to the 4 times my du, which is 6x e to the x squared, minus my u, which is 3e to the x squared, times my dv, which is 8x cubed, all over v squared. Square this thing here, square the 2, you're going to get 4. Square the x to the 4, you'll get x to the 8. And then it's a bit of tidying up time here. So let's just tidy this up. That's going to be 12x to the 5 e to the x squared minus 24x cubed e to the x squared all over 4x to the 8. So what I would do here is I would pull out a 12x cubed e to the x squared on the top line. It's being multiplied by x squared minus 2, yep, and all being divided by 4x to the power of 8. And then you would, to get your full marks, you definitely need to cancel out here. So my 12 goes into the 4, the 4 goes into the 12 three times, and then that x cubed on the top cancels into the x cubed on the bottom, x to the 8 on the bottom, so you're going to be left with x to the 5 on the bottom line, then e to the x squared minus 2. I would imagine you get full marks for that, but you may want to put it in one line. So 3x to the minus 5 e to the x squared upon x squared minus 2, which is definitely going to give you your marks. Okay, part B says integrate the following expression with respect to x. So let's just write this, our integral then, write it in index form. It's 4x to the 5 plus a half times x to the minus 1, then minus 3e to the minus x dx. So if you integrate that, and the only hard one really there, sorry, let's not write that one that way at all, that was silly. Write that as a half times 1 over x. So then if we integrate this one here, if you integrate e to the mx with respect to x, what you get is 1 over m e to the mx plus c. So here we can get started these and raise the power by 1 for the first one. Just raise the power by 1 divided by the new power. I think that's it. Is that a 5? My handwriting's terrible. Apologies. That's a 5. And then so that's going to be 4x to the power of 6 divided by the new power 6 and plus a half. Integrate 1 over x, you'll get ln of x. And then here, if you do this, then it's going to be minus 3 e to the minus x divided by minus 1 by using this definition here, and plus c, tidied up, and that's going to be 2x to the power of 6 over 3 plus a half ln of x, and then plus 3e to the minus x, and then plus your c. Okay, and last one of these, we've got to integrate sine of x cos cubed of x dx. We're going to do this by inspection, so I'm going to differentiate, raise the power of the cos by 1, so it goes cos to the 4, and differentiate to see what I get. So if differentiate cos, you get minus sine, so it's going to be minus, differentiate with respect to the power, you'll get 4 cos cubed x, and then I have my minus sine, so there we are. That's what we've got. Not quite what I was looking for, so if I differentiate minus a quarter of that, I will get what I'm looking for. I'll get, I'll write it their way, sine of x cos cubed of x. That means if I differentiate this thing, if I differentiate the thing in blue, I get the thing in yellow. That means if I integrate the thing in yellow, I will get the thing in blue. So that is just going to be minus a quarter cos to the power of 4 of x plus your constant of integration c. Question 4, we are to prove that the sum of the first n terms of a geometric series are given by this. So the way we do this is we write down the general expression for the sum of the whatever number of terms. So we're just going to write down your s of n is equal to, so your first term would be a, your next term would be ar, your next term would be ar squared, all the way along. So your nth term would be ar to the n minus 1, ... That's your equation 1. If you then multiply that by r, so r times s of n is ar plus ar squared plus ar cubed plus, and all the way along, you're going to have an ar to the n minus 1, but then your last term is going to be ar to the power of n, and that's your equation 2. Now, if we just do your s of n line minus your r s of n, what happens? You can see this term will cancel out with this one will cancel out with this one. There's something here, it'll cancel out with this. This one gets cancelled out with this, so you can see all you're left with is a minus ar to the power of n. So factorize on the left, you'll have s of n upon 1 minus r. Factorize on the right, you'll have a times 1 minus r to the power of n. and then just divide across. Your Sn is equal to a upon 1 minus r to the n divided by 1 minus r as required. Happy days. Next question says, a child builds a tower from cube-shaped blocks which decrease in size. The largest block has a height of 10, so the one at the bottom, and each subsequent block has a height 90% the size of the previous. The first 3 blocks are such that they're shown. So what is the size of the 8th block? So the question asks, what is the height of the 8th block? So here in this is an AP. Your first term is 10. Your second term then, or how you get from the 10 to 9 is you multiply by 0.9. So your general term would be a times r to the power of n minus 1. So in this case, our 8th term is 10 times 0.9 to the power of 7. So if you did that out, it would be 4.78 centimetres to 3 sig figs. Remember, 3 sig figs is what we're looking for here in this exam. Next one says, I might be able to squeeze this in this wee bit here so we can see it. It says here, you've got to find the minimum number of blocks the child will need to build a tower with a height of at least 90 centimetres. So we're using our SN formula. Let's just write down what that was. We were given that earlier on. That's 1 minus r to the power of n, a upon 1 minus r to the power of n over 1 minus r. And we want this thing, so if we put in our values, so 10 minus 0.9, to the power of n, all over 1 minus 0.9, we want that to be greater than 90 centimetres. We want that to be greater than 90 then. And then we can just tidy up a wee bit. That's 10 upon 1 minus 0.9 to the power of r. 0.9 to the power of n, sorry. Let me fix that. 0.9, that should be in there. And that's all divided by, that was all divided by 1 minus 0.9, which is 0.1, and that's greater than 90. Multiply across by that 0.1, you'll have that's going to be just 10 upon 1 minus 0.9 to the power of n is going to be greater than just 9. And then what could we do? We could then just divide across by the 10, I suppose. So 1 minus 0.9 to the power of n is going to be greater than 0.9. And then we'll do a wee bit of switching around here. You'll have 1 minus 0.9 then is going to be greater than 0.9 to the power of n, which is just 0.1 is greater than 0.9 to the power of n. I'm just going to write that the other way around with my arrow pointing this. I just don't like working with my n on my left hand, on my right hand side. And then what I'm going to do is take logs. So I'll say n log of 0.9 is less than log of 0.1 or ln of 0.1. And then divide across your n. And let's see what happens here. The inequality sign has to change direction. The reason it has to change direction is if you do ln of 0.9, you will get a negative. So it's going to be then n is greater than, and that works out as 21.85. So n is equal to 22. So you need 22, I think we were talking about blocks, and that's it. Okay, next bit says, in theory, the maximum possible height of a tower is 1 metre. So what they're talking about is a maximum is really your sum to infinity. The sum to infinity formula is this. So I can understand what they actually meant by this, but that's just what they're talking about. So the sum to infinity is going to be 10 divided by 0.1, which works out as 100 centimetres, which is 1 metre. So that's where they're getting this thing. So in theory, the maximum height of a tower is 1 metre. Why is it not feasible in practice? And the reason is you can't put down, that would be if you had an infinite number of bricks. Can't put down an infinite number of bricks or blocks, I think it was they called it, of blocks. So you can't put down an infinite number of blocks. So that's why it's only in theory that the maximum height would be 1. In reality, you cannot do that. Okay, right, lovely bit of trig here. It says, prove that cosec to the power of 4 minus cot to the power of 4 is equal to cosec squared plus cot squared. Now let's look at the left-hand side. This is a difference of two squares. We've got cosec squared theta minus cot squared theta upon cosec squared theta plus cot squared theta. And I would just say at the side here, I'd just say, remember, sine squared theta plus cos squared theta equals 1. To get cosec, you need to divide through by sine. Sine squared divided by sine squared is just 1. Plus cot squared divided by cot squared. Cos squared divided by sine squared is cot squared. And 1 divided by sine squared is cosec squared. And that means if you did cosec squared theta minus cot squared theta, you're just going to get 1. So this first bracket then just becomes 1, then times cosec squared theta plus cot squared theta, which just of course is equal to cosec squared theta plus cot squared theta, which equals your right hand side. So a very nice wee proof indeed. The next one says, hence or otherwise solve the following equation. This thing then we have just said is the same as cosec squared theta plus cot squared theta, and then is equal to minus 3 cot. We want to get everything in terms of cot. So your cosec squared, you write as 1 plus cot squared from what we had above. And then that's plus another cot squared is equal to minus 3 cot theta. That's going to be 2 cot squared theta plus 3 cot theta plus 1 then is equal to 0, which factorizes to be 2 cot theta plus 1 times cot theta plus 1 equals 0, which means cot theta is equal to minus a half, or cot theta is equal to minus 1. So going on from there, what do we have there? Cot theta equals minus a half, sorry. That means, tan theta is equal to minus 2, and the other one was cot theta equals minus 1, which meant tan theta is equal to 1 over minus 1, which is just equal to minus 1. We've got to do the cast diagram now for these. Remember our range, it was in radians, and it was from 0 to 2 pi. So cos, if you do your basic angle, first of all, you'll get 1.107, and it was negative, so it's going to be in here and in here. So that's 1.107, 1.107. And we're going round to here and all the way round to here. And for this one, that's a nice one. Basic angle then, calculate in radians mode, it's pi over 4. And again, C, A, S, and T. So there's my 0, sorry, I should have marked that in the first one. And it was pi over 4 and pi over 4. So round to here is pi over 4 shy of being 1 pi, and here is pi over 4 shy of being 2 pi. So let's look at these ones then. This first one, 180 minus this, is going to give me 2.03 radians to 3 sig figs. The next one, so this one in yellow now, the second one in yellow, is going to be 2 pi minus 1.107 is going to give me 5.18 radians, and these ones give you nicer ones. This one here in green is going to be pi minus pi over 4, which is going to be 3 pi over 4 radians, and the other one then, we'll do it in green, all the way around to here is going to be 2 pi minus, that is going to be 7 pi over 4 radians. Okay. And what else we got to do? Oh, this is very common. If you haven't revised this for your exam, folks, going in, you have not prepared anywhere well enough. This comes up nearly every single year, so just you know that. You should be knowing how to do these questions. It says, write 3 cos theta minus 5 cos sine theta in the form r cos theta plus alpha. So we're going to write that out first of all. R cos theta plus alpha, that's in a bracket there, is equal to, sorry, I've not put any, that's going to be the same as, then, that's r cos theta cos alpha minus r sine theta sine alpha. Okay, and then what we have got then, we know that means your 3 equating your cos thetas. So cos thetas being multiplied by 3, and our cos theta here is being multiplied by 3 cos, by r cos alpha. So that means r cos alpha is equal to 3, and then equating your sines. So it's a minus 5, but this is already a minus 1 here, so it's just, so 5 is equal to r sine alpha. So r sine alpha is equal to 5. And then what you can do is get tan of alpha by doing 5 over 3, which allows you to get alpha. And I got 59.0 for that one. And also you can get your r by just squaring those two things, the 3 squared and the 5 squared, and square root. And my r worked out to be root of 34. I've got my marks for that. I defined, oh no, I didn't have to write it in that form then. So I have to then go, my answer, that's what it was, root 34 times cos of theta plus 59.0. I know you don't need that 0 in for calculations, but put it in just because it did say for 3 sig figs. But leave this thing as root 34. It's exact, it's perfect. That's the best way of doing it. Okay, next thing it asks you to do is hence find the maximum value of the expression. Now what this is here is is what we've just done here. So this thing is equal to 8 minus, let me just check that. Yep, 8 minus, that's our r cos theta plus alpha. And remember the numbers we had here. So that's what we had. And we want to find the maximum value of this thing. So the maximum value is going to be 8 plus root 34, which works out to be 13.8 to 3 sig figs. And that happens when the cos of theta plus 59.0 equals minus 1, i.e. theta plus 59.0 is equal to 180 degrees, which means theta is equal to 180 minus a 59.0, which means theta is equal to 121 degrees, again, to 3 sig figs. Okay, next one is a binomial expansion one. It says find the binomial expansion of this. How I do these is I will get it in the form 1 plus squiggle. I know it's not very mathematical, to the power of n, but that's equal to 1 plus n times the squiggle plus n times n minus 1 times the squiggle squared divided by 2 factorial plus, we don't need this term, but just to show you, n minus 1, n minus 2 times the squiggle cubed all over 3 factorial. So we're going to look at this thing and we're going to have to try and get it in the form 1 plus something. So I'm going to do that by taking out an 8 outside the bracket, which leaves me 1 minus 2x over 8. And then that whole thing is to the power of 1/3. That means 8 to the power of 1/3, and also 1 minus, I'm going to tidy that up a wee bit, make life a wee bit easier. It's just 1 minus x over 4 to the power of 1/3. Cubed root of 8 is 2, so it's 2 upon 1 minus x over 4 to the power of 1/3. Now, this is in the form 1 plus squiggle. The squiggle is brackets minus x over 4. So everywhere I see squiggle up above, I'm thinking minus x over 4. So if we expand this out, you're going to have 2 times, 1, and then it's going to be plus my n, which is 1/3, times the squiggle, which is minus x over 4, plus, next one's going to be 1/3, times minus 2 over 3, times minus x over 4 squared, all divided by 2. then plus, and so on. So that's going to be, if you tidy it up, that's 2 upon 1 minus x over 12. Tidy this all up, not easy to do. That's going to be x squared over 144. So just when you're doing that, folks, just be careful. Where people make a mistake is they forget to square this 4 in the bottom line. So that's going to be positive x squared over 16 when you square that bracket. So just be very aware of that. And so on. And then here, that's going to be 2 minus x over 6 minus x squared over 72. And so on. That's as good as we can go. 5 easy marks. Use expansion. Oh, I've missed a bit. It says state the range of values of x for which this expansion is valid. Okay. 1 plus squiggle to the power of n is valid for modules, so squiggle is less than 1. That's how you want to learn it. And here, this thing would ever work for me. So our thing was, what did we have? It was 2 upon 1 minus x over 4, the power of a third, that's what it was. So modulus of minus x over 4 has to be less than 1. That's the same as modulus of x over 4 is less than 1. Multiply across by the 4, modulus of x is less than 4. It's only 1 mark, but it's an easy mark, you might as well get it. Okay, it says, use expansion obtained in part 2 to show that the cube root of 7.1 is approximately equal to 1.9222. So let's just look at root of 7.1. Cube root of 7.1, that would be 8 minus 2 times 0.45 to the power of 1/3. Let's think about why that is. 0.45 times 2 gives you 0.9. Take away from 0.9, take away 0.9 from 8, you get 7.1. And the power of 3 means your power of a third, means your cube root. Okay, so you can see clearly what we are trying to do here. So we can just fire that into our expansion. And our expansion, remember, was 2 minus x over 6. Let me just write that down. 2 minus x over 6 minus x squared over 72. That's what our expansion was. So we're just going to do then, this equals 2 minus 0.45 over 6 minus 0.45 squared over 72, which is equal to 1.9222 to 5 sig figs. And you know you've got your marks there, as I tell you, very nice. Now, the next bit of this question, it says when a calculator is used to find the cube root of 7.1, the answer is, a wee bit different than ours, 1.9220. So just one way to improve the approximation found in part 2, showing that this agrees with the calculator answer to 5 sig figs. So what we only went up to x squared. So what we could do is expand this series to x cubed. So let's just look at the x cubed term. So the x cubed term, so going back to what we had earlier on, so it would have been 2 times my n. Sorry, the x cubed term, let me just write that in. It's going to be n times n minus 1 times n minus 2 times whatever it was cubed all over 3 factorial. So for us, remember you had the 2 outside the bracket as well. So it's 2 times my n, which is a third, times minus 2/3, that's my n minus 1, times minus 5 over 3, that's my n minus 2, times my minus x over 4 cubed, divided by, and then 3 factorial, which is 6. If you work it out, you'll get 5x cubed over 2592. So when you put in x equals 0.45, your x cubed term is equal to minus 5 times 0.45 cubed all over 2592. So that means, we'll just say, so the expansion to the x cubed term, you've you've got your cube root of 7.1, it would be 1.9222. Remember, that's what we got going up to the x squared, and then minus 5 times 0.45 cubed, all over 2592. And when you did that, you got 1.9220 to 5 sig figs. Question 7 is an integration by substitution question. It says use the substitution u is equal to 2 minus x to find the integral of x upon 2 minus x to the power of 12 dx. So I just like to call that I, my integral, and I'll just say u is equal to 2 minus x. First thing you do is you do du by dx, which just gives you minus 1. Then if you separate the variables, so it's as if you're multiplying across by dx, that tells you the integral of du, or the integral of minus dx changes to the integral of du. So let's just change that. That means minus the integral of du is what you're going to change your integral and dx. So far we've changed our integration sign on our dx. We now need to sort out this x and this 2 minus x to the power of 12. So the 2 minus x to the power of 12 will do it. That's just u. So it's just going to be u to the power of 12. So we're just left to sort out what x is. So we'll just rearrange this thing here, and bring the x across and swap the u across. You'll have 2 minus u. So your integral could become minus, remember that's how we replaced our integration sign, and dx was minus the integral of du. The x then just becomes 2 minus u, and the 2 minus x, all to the power of 12, just becomes u to the power of 12. Now multiply that out, and you're going to get the integral minus the integral of 2u to the power of 12 minus u to the power of 13 du, and then we're just going to integrate this. Now probably easier to multiply in by that minus. So multiply in by that minus, and you're just going to get the integral of u to the power of 13 minus 2u to the power of 12 du, and then if we integrate, you're going to get u to the power of 14 over 14 minus 2u to the power of 13 over 13 and plus c. Now the trick here is, instead of just firing in the x at this stage, take a common denominator. 13 times 14. So 13 times 14, just check, is 182. So that's 182. So the u to the power of 14 needs to get multiplied by 13. And the 2u to the 13 gets multiplied by 14, so that's minus 28 u to the power of 13, and then plus your c. I would just, at this stage, I'd probably just write this as, or factorize the top line. I could pull out u to the power of 13, and inside is going to be 13u minus 28, all over 182 still, plus c. And then my u to the power of 13, what was u? U was 2 minus x, that's the power of 13, and then we had 13 times u, so that's 13 times my u, which was 2 minus x, then minus 28, plus c, all still over 182, and then I'll take that 182 out the front, so 1 over 182, then times 2 minus x to the power of 13, and then you've got 13 times 2, and then minus 28. 13 times 2 is 26, minus 28 would be minus 2, and then minus 13x and plus c, and probably you could take a minus outside this bracket, so it becomes then minus 1 over 182 times 2 minus x to the power of 13, and then that's going to be, you've taken a minus out, so it becomes positive 13x, positive 2, and then plus your constant of integration. Question 8, the first part, is a using partial fractions question. Show that 1 over p upon 5 minus p is identically equal to 1 over 5p plus 1 over 5 upon 5 minus p. Now how I would do this is I would separate the variables, write it as start as partial fractions, still in the last question here. Start as partial fractions, so 1 over p plus 5 minus p is equal to a over p plus b over 5 minus p. And then multiply across by this, multiply across by that thing there. And what you're going to get is 1 is identically equal to a upon 5 minus p plus b upon p. and then you can do this whatever way you want. I think in this one I would just let p equal 0. Let p equal 0. So my left-hand side is still 1. My left-hand side is still 1. My right-hand side is going to be 5 times a. And this bit here goes to 0. So you just have 1 is equal to 5a. A is equal to 1 over 5. Put that in a box. Also what I could do is let p equal 5. So then on the left-hand side I've got 1. The right-hand side, p equal 5 makes that bracket equal to 0. 5 minus 5 gives you 0. So you've just got 5b. And a wee bit of working out, then your b is equal to 1 over 5. Therefore, I have shown that 1 over p upon 5 minus p is equal to 1 over, well here, I'll show the steps just so it's really clear I understand what's going on. That's 1 over 5 over p, and then plus 1 over 5 over 5 minus p, and then that is the same as that 1 over 5, that 5 can come on the bottom line, so it's 1 over 5p plus 1 over 5 upon 5 minus p as required. Now the next part of the question will call back to this, so I'm just going to write that down that I've got that I can clearly see this bit in yellow. I will be using this again. This is why they were really kind to us in this exam, the way they set the question out in a way that if you couldn't get the first bit, you could still use it for the next part of the question. So a well-written exam, I have to say. A planner models the population growth of a city by dp by dt is equal to 0.006 p upon 5 minus p, where p is a population in hundreds of thousands at a time t years. And it says when t is equal to 0, so that's initially, so the initial population is p is equal to 4, so that's 400,000. By solving the differential equation, find the value of p when the population is 450,000. Okay, let's look at our differential equation which they gave to us. It was 0.006p upon 5 minus p. And then we'll separate the variables. So that's 1 over p upon 5 minus p times dp by dt is equal to 0.006. Separate the variables. So that means 1 over p upon 5 minus p. dp is equal to the integral of 1 over p upon 5 minus p. dp is equal to 0.006 integrated with respect to p. Now this left-hand side, let's just look at this bit. This should hopefully be familiar to you. This is what we had over here. So we can write that as the integral of 1 over 5p plus 1 over 5 upon, 5 minus p dp is equal to, and that'll be the integral of 0.006 dt. Now this left-hand side, I can make life a wee bit easier by taking out 1 over 5 outside the integral. Hopefully this makes it a wee bit easier. And my right-hand side, I'll just integrate this right-hand side. I'll get 0.006t plus a constant of integration. If I integrate my left-hand side, then I'll get 1 over 5 times, and that's going to be ln of p minus ln of 5 minus p. They both should be modulus strictly, and then is equal to 0.006t plus c. Now where have I gone to here? I've scooted back to the very start of the paper. Apologies, right, bear with me. Okay, apologies, right. So what I would do here is I would probably multiply through by that 5. So the 1/5 that comes across and multiplying by 1/5, opposite of that is multiplying by 5. So 0.006 gets multiplied by 5 to give you, I'll just leave it as a decimal, that's 0.03t. Now you could, don't do this please, but you could write that 5c. We haven't assigned the value to that c yet, so just leave it as 5c. I know people think that's a wee bit weird. If you really don't like what I've just done, call it 5c. And then the left hand side, inside this bracket, so this bit here, you could write, using your third rule of logs, you could write that as ln of p over 5 minus p. So that's what you've got. Let's bring that across a wee bit, tidy it up somewhat. So that's what we've got. So far, so good. Okay, next thing we want to do then is we want to put in our values. So it tells you in this question, when t is equal to 0, p is equal to, and it said when t is equal to 0, capital P is equal to 4. So let's just put that in. So that's ln of 4 over 5 minus 4 is equal to then, what's that going to be? Sorry, 0.03 times 0 plus c. So that tells me that ln of that's just ln of 4 on the left hand side is equal to c. So I've got a value for my ln of c. There's other ways of doing this, and I'll show you that in this video as well. I'll go from here and show you another way of doing this. So that's what one way of doing it. Then that means what you've got is ln of p over 5 minus p is equal to 0.03t plus ln of 4. Now what you could do, it asks you to find what the population is when, or find the value of t, or find the time when the population is 450,000. So I would say when the population is 450,000, p is equal to 4.5. So let's just put that into this equation. And this is not my preferred way of doing this, by the way, but we'll just see. That's going to be ln of 4.5 over 5 minus 4.5, and that equals 0.03t plus ln of 4. So if you do that, sort out that left hand side, what you've got is 0.5 divided by 4.5 over 0.5. That's going to be ln of 9 is equal to 0.03t plus ln of 4. I'm trying to get as nice an answer as we can. That's going to be ln of 9 minus ln of 4 is equal to 0.03t. And then that's going to be ln of 9 over 4 is equal to 0.03t. And I could just say ln of 9 over 4 divided by 0.03 is equal to my t, I should have said. And let's just check out of my calculator. Ln of, what have I said, 9 divided by 4. And then divided by 0.03. And what I got was t is equal to 27.031. So basically it's 27 years. Okay, that's not my preferred way of doing it, to be honest. I'm going to look at and do this a slightly different way. So there's one way of doing it. There's lots of different ways of doing it. As long as you're getting 27 years, you've got the right answer. So there's so many different variations of this. Okay, right. I said I would go from here. Let me just get some straight lines on this page. So here, I'm going to go from this. What did that say? Ln of p over 5 minus p is equal to 0.03t plus c. Ln of p over 5 minus p is equal to 0.03t plus c. And they tell you when t is equal to 0, p is equal to 4, but we're not going to use that just yet. So that's what we're going to use in a minute. But before that, I'm going to write this as p over 5 minus p. And the inverse of doing ln is e to the power of, so 0.03t plus c. And then you could write that as p over 5 minus p is equal to e to the 0.03t times e to the c. And then you say capital A is equal to e to the c. So that means p over 5 minus p is equal to a, e to the 0.03t. And then we're using our thing, or initially, t was equal to 0 when p was equal to 4. So 4 over 5 minus 4 is just going to be 1. So 4 is equal to, and it's just a times e to the 0. Therefore, your a is equal to 4. So your equation becomes p over 5 minus p is equal to 4 e to the 0.03t. And then just say when P was equal to 4.5. Remember, that was 450,000. That means 4.5 over 5 minus 4.5 is equal to 4 e to the 0.03t. This would then work out to be 9 is equal to 4 e to the 0.03t. This should be looking familiar to you. 9 over 4 then is equal to e to the 0.03t. Take lins of both sides. Lin of 9 over 4 is equal to, e and lin cancel each other out, so right hand side is just 0.03t, and then lin of 9 over 4 divided by 0.03 is going to be equal to your t. So again, 27.031. So t is equal to 27 years. Now, probably a bit longer, the method that I prefer, but that's still the one I prefer. There we go. And you can sort of see them sort of side by side. You can see a lot of the similar bits there. So that's why you're getting the same numbers. Okay, this next bit, first bit is lovely. Again, they've been really nice just the way they've shown you this. So you can easily make a mistake in a question, but they know they're sort of leading you through it so they can you can find out if you've got this right. So it's a nice way for you to correct any mistakes then. So x squared, it's an implicit differentiation. Curve is defined by the equation x squared plus 4xy plus y squared plus 12 is equal to 0. And you've got to show that dy by dx is equal to this. So what you're going to do is differentiate everything with respect to x. There's some easy things, some not so easy things. So first thing, x squared differentiates with respect to x really easily to give you xy. And then the next thing, and I would just use a bracket for this. So this is a product, so it's going to go in here. So the way I do a product is I differentiate the first. So the 4x gets differentiated as just 4, and write down the second. And then write down the first, and then differentiate the second. So the second bit is y. Differentiate y with respect to x. What you get is dy by dx. Now, this bit is me differentiating y squared. Can't differentiate y squared with respect to x, but you can certainly differentiate with respect to y to give you 2y, and then just slap on a dy by dx. So that's your method to differentiate something in terms of y with respect to x. So for example, if I had 8y cubed, I wanted to differentiate with respect to x, differentiate with respect to y to get you this, and you just fire on dy by dx. As easy as that. It comes from the chain rule. I'm not going to go into where that comes from, but that's where it does come from, but that's as easy as it is to do it. And the last thing, differentiate 12 with respect to x, you get 0, and differentiate 0 with respect to x, you get 0. Okay, that's tidy up. Let's group all of the dy by the x's together. So I've got 4x plus 2y. That's all the dy by the x's I've got. Everything else I'm going to fire over the other side. And then dy by dx then is equal to minus 2x minus 4y over 4x plus 2y. Top and bottom divide by 2 to give you minus x minus 2y all over 2x plus y. And yep, that's what we're looking for. We know we've got 5 marks. What a great place to be in an exam. Okay, right. The next question says, point A lies on the curve. The tangent to the curve at the point A is parallel to the y-axis. The x-coordinate of A is negative, hence find the coordinates of A. Okay, right. How I'm thinking about this. I'll do this in red. This is really what's going on in my head. Not really too sure. What if it's parallel to the y-axis? I've had a blank. So let's think about what it means if you're parallel to the x-axis. If parallel to the x-axis, then the gradient equals 0, i.e. the top line of gradient equals 0. So what I mean by that is this bit here, if it's parallel to the x-axis, this bit here would be 0. Okay? Now, so that means, so if it's then the opposite, it's not parallel to the x-axis, but it's parallel to the y-axis, then the gradient, you could say gradient is equal to, instead of 0, it's going, because it's not horizontal, it's going straight up, so the gradient's actually infinity, i.e. the bottom line of the gradient equals 0. So that's quite tricky. So that's how we look at this. So if this bit's equal to 0, there's what's called a discontinuity. That means it's shooting up, straight up in the air. So if you think back to the, like what, 1 over x, for example, it shoots up here and here because you get a 0 on the bottom line at x equals 0. So that's why there's the asymptote here. That's why it's going straight up in the air. So to get it parallel to the y-axis, we want to get a 0 on our bottom line of our gradient function. So what we want to do here, where have I gone here? So we want to just say put the bottom line equal to 0. So the bottom line was 2x plus y equals 0. A wee bit of working out means y is equal to minus 2x. Now what you could do is then substitute that into the original curve. And I'll write down what the original curve is. So sub that into, what was the original curve? X squared. So I'm looking back on the question paper. X squared plus 4xy plus y squared plus 12 equals 0. So everywhere I see y, I'm replacing it with minus 2x. So x squared plus 4x instead of y minus 2x. Instead of y squared, it's minus 2x all squared. And plus 12 is equal to 0. So that's going to be x squared minus 8x squared plus 4x squared plus 12 equals 0. And that's going to be, then that's going to be 5x squared minus 8x squared. That's going to be minus 3x squared plus 12 equals 0, which is very nice. That means 12 is equal to 3x squared, which means 4 is equal to x squared, which means x is equal to plus 2 or minus 2. We are told in the question, the coordinate of a is negative. So just say i.e. x is equal to minus 2. And then we'll just say, just finish this off here. When x is equal to minus 2, my y is equal to, and we're just going to put that into minus 2 times the x, so minus 2 times minus 2, so y is equal to 4. So the point A is minus 2, 4. Let me just check, that's definitely all we need to do. It says tangent to the curve at a point A is parallel to the y-axis, the x-coordinate is negative, hence find the coordinate of A. We've done that, happy days. Okay, next question, question 10. Tricky enough question, I think. It says, but this first bit's nice enough. It says, a curve is defined parametrically by x is equal to 3 plus tan theta, and then 1 over y plus 3 is equal to cos theta. Find a Cartesian equation of the curve. Okay, we've got a tan here. I'm just going to write down my relationship sine squared theta plus cos squared theta equals 1. Can't really use that one particularly easily. If I divide that through by cos squared, I'll get tan squared theta plus 1 is equal to sec squared theta. And here, this one I could change this. If I reciprocal both sides, I'll just get y plus 3, and the reciprocal of cos is sec. Oh, here, happy days. That looks like it could be, this could work for me then. So I'm just going to also then make tan a subject. So tan is going to be the same as x plus 3. So we are good to go with this then. So that means we're just going to write that down, the equation. What was it? Tan squared theta plus 1 is equal to sec squared theta. So that means, oh sorry, that should have been tan is equal to x minus 1. Apologies, tan is equal to x minus 3. So then if we put that in, then that's going to be x minus 3 squared plus 1 is equal to, then the sec squared is y plus 3 squared. Now let's do this out, as I've said nearly every video I've done so far this year. Do this out the long way. to avoid making the mistakes. So that's going to be x squared, x times x is x squared, x times minus 3 is minus 3x, minus 3 times the x is another minus 3, so that's minus 6x, minus 3 times minus 3 is plus 9, and then you plus 1 over here. Y times y is y squared, y times 3 is 3y, 3 times y is another 3y, that's 6y, and plus 9. And then that tallies up to be x squared minus y squared minus 6x minus 6y plus 1 equals 0. Okay, we waste a page here for the next bit, and then we're on to this. This is a fairly tricky question here, so bear with me here. Okay, it says the curve has two turning points. Use a parametric differentiation to find the coordinates of the curve's turning points. Show working to identify the nature of the turning points. So remember what we had. We had x was equal to 3 plus tan theta, and we had y plus 3, remember, was equal to sec theta. You could rearrange that and say y is equal to sec theta minus 3. So we've got those. Now what we need to do is parametric differentiation, which is dy by dx is dy differential with respect to theta times d theta by dx. So do your dy by d theta, and if you differentiate my y, so I'm differentiating this thing over here, dy by d theta, differentiate sec, what you get is sec theta tan theta, and do my dx by d theta. I'm just going to get, if you differentiate tan, you get sec squared theta, which means, and we need, remember, we need d theta by dx, so reciprocal sec squared, you're going to get cos squared theta, which means dy by dx then, remember, is equal to sec theta, tan theta times cos squared theta. And what does that look like then? Sec is the same as 1 over cos. Tan is the same as sine over cos. And if you're multiplying both of those by cos squared, multiplying that term by cos squared, you're just going to get sine theta. So after all that work, your dy by dx is just sine theta, which thankfully is manageable for us to differentiate again. Okay, that's what my dy by d theta is. I'm just going to put that in a box, so I've got that sacred somewhere. What else I'm going to need later on, because I'm going to have to do my second derivative, I'm going to need this. So I'll put this in a box. I'm going to need both of these things later on. So that's what we've got. We want to find a turning point. So at a turning point, at a TP, dy by dx equals 0. So you just put 0 equal to sine theta, and must be in radians here. So sine theta equals 0, and you can do this even on your calculator. Just do sine to the minus 1 of 0 if you forget. Sine to the minus 1, so that means theta is equal to 0. And on your cast diagram, 0 is here, and the opposite place it's also going to be 0. So that's going to be, or theta is equal to pi. So that's where you get those from very easily. They're both in radians. Okay, at this stage I think I'll find the corresponding x and y values. So I'm just going to say here, I'll squeeze this at the bottom here. When theta equals 0, my x is going to be 3 plus tan of 0. Just check, tan of 0 is 0. So 3 plus tan of 0, so that's just 3. And also the y, and the y is equal to sec theta minus 1. Sec, remember, is 1 over cos. So that's going to be 1 over cos of 0, and minus 3 it was. So that's just 1 over 1. So that's just 1 over 1, which is 1 minus 3. So y is equal to minus 2. So that gives me the point 3 minus 2. So that's one of my turning points. We'll do the other one here and go on to the next page. So we'll just say when theta is equal to pi, when my theta is equal to pi, what will I have? I will have my x value then. My x value was 3 plus tan of theta, so 3 plus tan of pi. So that's 3 plus tan of pi. And that worked out as 3. Sure, I knew that was equal to 0. So that's just going to be x is equal to 3 again. And the y value was going to be 1 over cos of pi, and minus 3. And that's 1 divided by cos of pi, and then minus 3 on the calculator. That all works out as minus 4. So another turning point is 3 minus 4. And when I first looked at this, I thought, how could this be right? Because my two turning points are directly above each other. But you have no idea what this looks like. You could well have a maximum and a minimum. You could have something like that. So it's a bizarre x squared plus y. Remember the Cartesian equation was x squared minus y squared. I have absolutely no idea how it works or what it looks like. So just go with it here. So I don't think our maths is wrong. It's just a weird looking curve. Okay, right, we've got our two turning points. Here they are. We'll just highlight them here for us. We have 3 minus 2 and 3 minus 4. So directly above each other, but we don't know their nature. So we need to find their nature. How you find your nature of a turning point is your d2y by dx squared. And then parametrically, what you've got to do is you've got to differentiate your dy by dx with respect to theta, and then multiply that by d theta by dx. Now both of those we highlighted up above. So our dy by dx was sine theta. So that means if you differentiate sine theta, you just get cos theta. And your d theta by dx, where on earth was it? D theta by dx was cos squared. So cos squared theta. So it all just works out to be cos cubed theta. So that's what you get for your d2y by dx squared. Okay, now just say when theta equals 0, d2y by dx squared, put theta equal to 0 into it. Cos of 0 is 1, cube that, you just get 1, which is clearly greater than 0. Therefore, 3 minus 2, that was a turning point which corresponded to theta equal to 0. So because it's greater than 0, d2y by dx squared is greater than 0. 3 minus 2 is a minimum turning point. And the other one was when theta is equal to pi, your d2y by dx squared is cos of pi, and that's cubed. Cos of pi was minus 1. Minus 1 cubed, that is just going to be equal to minus 1, which is less than 0. That means the other turning point, which the one which corresponded to theta equal to pi, which was 3 minus 4, it will be a maximum turning point. So I think we've done what we've been asked. Let me just read that back. Use parametric differentiation to find accordance to the curve's turning points. Show working to identify the nature of each turning point. So there we go. 13 marks. That certainly was not an easy 13 marks. There was a lot of work going on there. It was a hard question. Question 11 is a pretty tricky integration question. It says a landscape gardener has designed a patio. The patio can be modelled by the shaded region R enclosed between the line y equals 2x and the curve y is equal to 4x cos 2x as shown in figure 2 below. The line and the curve intersect at the points O, A and B. Show that the coordinates of A and B are pi over 6 and 5 pi over 6 respectively. So again, they've been very nice to you. Even if you can't find those points, they give you the points that you can do the latter parts of the question. Okay, the curve was y is equal to 4x cos of 2x, and your line is y is equal to 2x. So just put those two things equal. So put 2x equals 4x cos of 2x. Bring it all to one side. You're going to have 4x cos of 2x minus 2x. And then I could factorize out a 2x, leaving me 2 cos 2x minus 1. So here, 2x equals 0, or else cos 2x is equal to a half. 2x equals 0 means x equals 0, and that was one of your points, remember? This point here, not the one we're looking for, however. And then we've got cos x is equal to a half. So what that does for us then, do your basic angle. So cos to the minus 1 of a half. So cos to the minus 1 of a half then is going to be, it's in radians, so it's pi over 3. So do your cast diagram, C, A, S, and T. Cos was positive, so it's in here. Your pi over 3 goes in here and in here. So it's going to be, my first angle, 2x is going to be pi over 3. And my second angle is going to be 2 pi minus pi over 3. That's going to be 5 pi over 3. Divide across by your 2, you're going to get pi over 6. And you're going to get 5 pi over 6. So there's another 3 marks. Not the easiest 3 marks in the paper, but 3 marks anyway. Okay, it says find the exact area of the shaded region R. Now the shaded region, to do this, the nicest way to do it, not that it really matters, but I would put during this region, the 2x's on top, and then the 4x cos 2x is on bottom. So I would do the 2x minus the 4x minus 4x cos 2x. So I'm going to just say my region, my area, is the integral of, it was 5 pi over 6 is my upper limit, pi over 6 is my lower limit, and then it's going to be 2x minus 4x cos of 2x dx. I'm going to call that equation 1. And I'm going to separate this because this bit is really easy to integrate. This bit here is a good bit harder. So I'm going to do that second bit first. The second integral, and then we'll come back to my area A, which I've called equation 1. So I'm going to investigate the integral of 4x times cos of 2x dx. Now I'm going to use integration by parts. Your u, I'm going to let it equal to 4x, and my dv by dx is cos of 2x. So differentiate your u with respect to x, you'll get 4. Integrate your dv by dx, you will get a half sine 2x. That means the integral of 4x cos 2x dx is equal to, so this, where this comes from by the way, it's integral of u dv by dx, integrated with respect to x, is uv minus the integral of v du by dx. So that's your integration by parts formula. So if we look at our integral, it's going to be uv, so that's going to be 4x times a half sine 2x. So that's going to be just 2x sine 2x. And then minus, and it's going to be my v du by dx. So that's going to be, I'm just going to write that as the integral of my v du. So a half times the 4x is just going to be 2, half times the 4, sorry, is just going to be 2 sine of 2x dx. And just to make life a wee bit easier, I'm going to take that 2 outside. I don't know if it's going to make this much easier at all, but I'm going to take that outside. And then I will integrate. That's already integrated this bit. 2x sine 2x. And then I've got my 2. Integrate sine 2x with respect to x. I'll get minus a half cos of 2x and plus a constant c. Tidy it up again. That's 2x sine 2x. And that's going to be plus cos of 2x plus c. So this whole bit has been integrated. So if I look back at this, my a is going to be square brackets. If I integrate this bit, I'm just going to get x squared, well, 2x squared over 2, which becomes x squared. And then this whole bit, I've shown how to do it. So it's going to be minus, and then it's going to be minus of, then it's going to be 2x sine 2x minus cos of 2x, and that is between 5 pi over 6 and pi over 6. So that's what we've got. So we're going to have to do a lot of work here. I'm going to have two square brackets. I'm going to be putting in all of these things. Putting in my limits, I should say. So put in 5 pi over 6 into x squared. You're going to get 25 pi squared over 36. They want exact, so you've got to leave it in terms of that. Then it's going to be minus, and then 2 times 5 pi is going to be just 5. 2 times 5 pi over 6 is going to be 5 pi over 3, and then that's going to be sine of 5 pi over 3, and then minus, and then that's going to be cos of 5 pi over 3. That's my first bracket. My second bracket, just lost something there, 5 pi over 3. My second bracket then, put in pi over 6 into that. It's going to be pi squared over 36, and then minus 2 times pi over 6 is going to be pi over 3, and that's going to be sine pi over 3, and then minus cos of 5 pi, nope, not 5 pi over at all, I'm sorry, minus cos of pi over 3 just. Okay, and then I think we'll start putting in values here. So sine of 5 pi over 3. So bear with me a wee second. Sine of 5 times the pi over 3 just works out to be minus root 3 over 2. So that becomes, that's 25 pi squared over 36 then. And then that's going to be plus, and that's going to be 5 pi root 3 all over 6. And then the next one, you put 5 times pi over 3 into the cos, and you get a half. So that's just going to be minus 1/2. So that's that first square bracket sorted. The second square bracket, I've still got pi squared over 36. And then it's going to be its sine of pi over 3, which was root 3 over 2. So it's minus pi root 3 all over 6. And then cos of pi over 3 works out to be a half. So that's going to be minus 1/2. So what happens here? You've got, let's sort these bits a bit at a time here. You've got this minus this, which is just going to be 24 pi squared over 36. Next thing, you've got this minus this, which is going to be plus, which is going to give you then, that's going to be 6 pi root 3 over 6. And then the last thing you've got minus a half, minus a half. So minus a half minus a half is plus minus a half, so that's it. And then what can we do here? That tidies up then to be 12 divides into 24 twice, so 2 pi squared over, and 12 divides into 36 3 times. And over here that's just plus pi root 3, and that's as good as we can go, I think it is. That's it. Okay, right, two functions are defined as follows. You've got your g of x and you've got your, your f of x and your g of x. So it says find a composite function gf stating its domain and range. Okay, right, let's look at this. And gf of x, what this means, first of all, that means you do g to your f of x. So, that means then what you do then is you fire in, you do g to your f of x, which is 3 over 2x plus 5. And then that just means the modulus of then 3 over 2x plus 5. Okay. Now, I think I would need to do a diagram for this one just to show you what's going on here. So you really could just sort of jump to the answer the domain shouldn't be too bad. The domain is where it starts. Now it starts anywhere belonging to the rails except x is not equal to minus 5 over 2. But let's just draw this thing out. I'm just going to draw this out just to be completely certain about this thing. So you've got your f of x is equal to this thing. So if you do that, first of all, it is it's similar to the 1 over x graph, but then what you've done is you've moved it 5 left first, and then you've stretched it horizontally scale factor 2, and then stretched it vertically scale factor 3 in that order. So if we just do that, your f of x graph, don't take this down please, but that's what your 1 over x graph looks like. And then you move it left by 5. So if you move that left 5, it goes to here then, where that's 5. Okay. Sorry, that's minus 5, I should say. And then if you stretch it horizontally, scale factor 2. Stretch it horizontally, scale factor 2. That then squishes in. So that asymptote then squishes into here. That's now going to be minus 5 over 2. And then stretch vertically as well. So it just looks like that. So that's what your f of x looks like. Okay, so if you draw the do the modulus to that, then what you're going to get, so g f of x is just going to look like this. So your g f of x is going to look like this. So that's just going to flip up vertically. Any bits that are underneath the x-axis are going to flip up vertically, and that is it. So very roughly, that's it. So your domain was wherever it exists, was x belong to the set of rails. So I'll zoom in on this, I'm very far right here. X belonging to the set of rails such that x could not be equal to minus 5 over 2. And you can see why that is, because there's a discontinuity there. And the range basically is the y values it covers. So it covers everything greater than 0. So your range is g f of x is everything belonging to rails such that it is greater than 0. And that's it. So I've maybe done more work than I needed to there. I need to do that work for these. I'm not good at functions. They're my least favorite thing to do. So I need to show that. Okay, getting there folks, we're almost at the end. It says a third function is defined by h, where h is equal to this. So find the range of h. Now I need to think of the range, I need to think about the y values that it's covered. So I'm going to do completing the square for this thing. So I'm going to look at my h of x, and I've hardly enough room to do this. So when you see the mark scheme for this, you'll see they'll have done it a very different way, no doubt. In fact, I'll maybe just say what the answer is because there's 1 mark. I have to do a lot of work here to get this 1 mark. So if you're better at these than me, good for you. I need to show my steps here for this. So I pull a 2 outside the bracket for this thing for the x terms. So that's what we've got. And then I complete the square. So that becomes half the coefficient, that is 5 over 4, and then squared plus 2. And then I must remember to take away 2 times 5 over 4 squared. And then that's 2 times x plus 5 over 4 squared. And then that would be, if you do that in your calculator, that's going to be minus 9 over 8. Okay, so this thing has a minimum value of minus 9 over 8. And it happens when x equals minus 5 over 4. Okay, right. Now, that means if I do a sketch of my curve, I have to do it up here because they haven't given me enough space. If you imagine, very roughly, that's what my thing is going to look like. The minimum value is there, and that was minus something at minus whatever. So that means I need to find out what this value is here. Now it could be there, it could be somewhere else. I need to find out what the minimum, where this thing crosses. It could be like that. It could also be like what? It could also be like this. Sorry, the more extreme version. It could also be something like that. So I need to find out where it crosses. So my minimum value still is over here, all out of my original domain. So we'll just say when x equals 0, h of x equals, and it just equals 2. So my range, and this is all they're looking for, the range is h is then going to be greater than 2. So it actually is like this graph. So it crosses at 2. So h then has to be bigger than 2. So the range is bigger than 2. So definitely there's quicker ways of doing that, but I just need that to understand, to visualize the thing, to see exactly what's going on. So you'll see in the mark scheme, I'll just have this written down for 1 mark. You'll maybe be thinking where that's coming from. So hopefully that explains to you where that does come from. Okay, now what I did certainly wasn't a waste of time here, because it says show that the inverse function h to the minus 1, inverse of h, sorry, is given by inverse of h is equal to minus 5 plus the square root of 8x plus 9 all over 4, and state the domain and the range. Okay, so RH of x, I could write it then as my 2 upon x plus 5 over 4 squared minus 9 over 8. And I'll just say I'm going to do the inverse function. So the order of this doesn't really matter. What you could do here is let your y equal this. This is what I'm going to do. And what you could do here is rearrange the formula, making x a subject. And then so you'll have x equals a function of y, and then change all your y's to be x's, and that will give your inverse. Or at this stage, I'm not going to do it this way, but at this stage you could change this and write this as x is equal to y plus 5 over 4, and rearrange now to make y the subject, and then your y, it would be in terms of x. So it doesn't matter which order you do it, you will have to rewrite your y's as x's at some stage. Okay, but I'm going to just leave the y as it is. Bring the 9 over 8 across. Okay, and then divide through by the 2. So you're going to have y plus 9 over 8 all divided by 2, which is ugly as sin. We're going to tidy that up. Okay, so that means you could take a common denominator on this left-hand side of 16. So 9 over 8 divided by 2 would be 9 over 16. And then that needs to be 8y, because 8y over 16 is the same as y over 2, so that's y. And that equals x plus 5 over 4 squared. And then I'll just go on to the next page, I think, here. So what do I have written down there? 8y plus 9 all over 16 is equal to x plus 5 over 4 squared. And then we could say then that means square root plus or minus the square root of that. So plus or minus the square root of 9 over square root of 8y plus 9 all over the square root of 16, which is 4, is equal to x plus 5 over 4. And then that means just we'll say x n equals minus 5 over 4 plus or minus the square root of 8y plus 9 all over 4. So xn is equal to minus 5 plus or minus the square root of 8y plus 9 all over 4. Therefore, your h to minus 1, now you rewrite it as minus 5 plus or minus 8x plus 9, square root of all that, all divided by 4. And just say only the positive root as the domain of h is restricted. Okay, so your answer then is h inverse of h is equal to minus 5 plus or minus 8x plus 9 square root all divided by 2. So the domain is x is greater than 2, and the range is inverse of x is greater than 0. So where does that come from? We look back at the original thing. You had this thing. It had the original function had a domain of x is greater than 0. Therefore, our range is greater than 0. And we worked out the range to be greater, h was greater than 2. That means our domain, so the domain of an inverse is the same as the range of the original, and vice versa. So that's where we've got those from. And that, folks, is the end of the exam. So pretty tough exam. I heard a lot of people saying it was very tough, and I looked at it and thought that's maybe not as tough as I thought, but when I worked through it, I thought, no, there are a lot of tricks in that, a lot of places for people to go wrong. So it was a very tough paper, I thought.